Okay, so when we talk about zeros and roots, we're talking about x-intercepts. Okay? All right, so the x-intercepts of a function are also called roots. They're also called zeros. Roots and zeros, okay? A polynomial function of degree n can have at most n real zeros. So for example, if you have a polynomial like x to the fifth plus 4y or 4x squared and so on, how many real zeros can you have at most? 5. This is a degree 5 polynomial. That means you can have 5 real zeros. So whatever number that is, whatever number that is what you can have. Okay, an even degree polynomial has an even number of real zeros, and an odd degree polynomial has an odd number of real zeros. Okay, let's continue with the notes. So the solutions to the equation f of x equals 0 are the zeros of the function. So let's make sure that makes sense. Say I have an equation. Let's say I have say this is a 0, right? This is on the x-axis. This is a 0. What is the y value here? 0. So guys, basically, whenever your equation is 0, that will tell you what the x is. Does that make sense? Okay. Any equation, if you set it equal to 0, meaning your y value is 0, f of x is 0, y equals 0, that will give you what the x value is. It's any x-intercept, the y value is always 0. Okay? So that's what that top line means. They are also called roots. Okay? If x equals c is the solution to the equation, then x minus c is a linear factor. And we'll talk about that more shortly, of the polynomial function. Linear factors can be found by factoring the polynomial. Okay? All right, next. So let's do this example right here. First of all, what can these all be divided by? X. They can all be divided by x. So guys, I always want you to find the greatest common factor if there is one before you start anything. Always start with the GCF. So we can divide all of these by an x. When I do that, x will be on the outside. And what's left at the very front? Yep, x squared. What's left here? 5x. And what's left down here? Minus, oh, sorry, 24. I don't know why I divided it by 3. Minus 24. Okay, so let's go ahead and factor this. What are two numbers that'll multiply to negative 24 but add to give you 5? So 8 times negative 3 is negative 24, and 8 minus 3 is 5. Okay, so these are my two factors. We're going to write this as x plus 8, and x minus 3. Okay, those are your linear factors. These are called linear factors because they just have x's. This would be quadratic because that's a squared. But all of these are single x's, so they're called linear. Okay? All right, so what are my zeros? You set each of your factors equal to 0. So if you set this one equal to 0, what is x? Just 0. So your x can be 0. If you set this factor equal to 0 and solve, what is x? Negative 8. And if you set this factor equal to 0, what will it be? 3. So those are your zeros. This one, because I set this factor equal to 0. So you set each of your factors to 0. Good question. Okay. Now, on a test, you will always see this written in order. So if you put this in order, it'll be -8 first, the 0, and then the 3. Okay, so let's try putting these in order. All right, so that is that. Let's continue. Okay, so let's do some more examples. I'm going to pick the hard ones. I'll do number 4 with you. Okay, I'll do number 4 with you, and then you guys will do 1 through 6. Okay. So let me do this one. First of all, can all of these be divided by something? No? Okay. So there's no greatest common factor. What I'm going to do is just think with me real quick. What are two numbers that, well, first I'm going to do 9 times 4. That'll multiply to 36, but combine to give me -37. -36, -1, thank you. So -36 times -1 is positive 36, but if you add them, you'll get -37. So this is how I'm going to write it. 9x to the 4th minus 36x squared minus 1x squared plus 4. Do you guys see how this problem is exactly the same as the top, the original? So let me show you. I'll highlight. 9x to the 4th, 9x to the 4th. The 4 matches the 4. Do you guys see how a -36x squared minus 1x squared is -37x squared? Okay, so I just kind of expanded it. Now that I expanded it, I can now do grouping, which we learned yesterday. Okay, so let's go ahead and group these together. All right, so I'm going to split it down the middle, and we'll do the GCF of each side. So what can these both be divided by? Yep, an x squared, and what else? What else? Yes, let's do 9. Okay, so 9x squared is your greatest common factor. That'll go on the outside. 9 divided by 9 will cancel. I have 4 x's on top, 2 on the bottom, so I'm left with x squared. Minus, what's 36 divided by 9? 4, and those x squares will cancel. Okay, so we did that side. Now let's do the GCF of the other side. What can these both be divided by? -1. So guys, if this is a negative right here, always divide by a negative, okay? So -1 will be on the outside. Those cancel. I'll have x squared. 4 divided by a -1 is a -4. Notice, what's in my parentheses match. If they both match, that means I did it correctly, okay? So let's go ahead and write my factors. My factors are x squared minus 4, and then 9x squared minus 1. The outsides go together. Those are my two factors. Okay, we're not done, because the whole purpose of today is to find, let's go back. The whole purpose for today is to find linear factors and solutions, okay? What I have right now is not linear. This is quadratic. How do we know it's quadratic? Yep, because it has a square on it. We want linear terms, okay? So what I'm going to do is I'm going to do what we learned yesterday, okay? So I'm going to come up here. How can I rewrite 9x squared so that it looks like this? A squared minus b squared. And we're going to use this rule here. This is called the difference of squares. So how can I rewrite this 9 so that I can square it? A 3, good, because 3 squared will give me this 9. And then put your x in there. So we rewrote that first one. And then the next one, well, we can just put a squared. 1 squared is just 1. Okay, so guys, let me highlight so you see how this makes sense. I want a squared, and that's what I have, an a squared. Okay, so that means my a value, because I want a plus b, is 3x. My b value is just this 1. And then you do the opposite, 3x minus 1. So those are your factors for the 9x squared minus 1. Do you guys know what the factors will be for the second one, x squared minus 4? Yep, x plus 2 and x minus 2. So guys, let me put your whole answer together. I'm kind of all over the place. Your final answer will be 3x plus 1 times 3x minus 1. And then x plus 2, and then x minus 2. These are all of your linear factors. Yes. Thank you, Chance, for saying that. Remember in our notes, I'm going to go back a few slides to the notes. Going to go back to the notes here. It says a polynomial of degree n can have at most n real zeros. Okay, and an even degree polynomial will have an even number of real zeros. So because we had our example started off with a 4, that's the leading degree. It's a 4th degree. That's why we have 4 linear factors, and we're going to have 4 solutions. So guys, let's go ahead and solve for the solutions. We're going to set this equal to 0 and solve. So it'll be negative 1/3, positive 1/3, 2, and negative 2. And put those in order. So the reason why I got this, 3x plus 1, if you set it equal to 0, you subtract 1. So you get 3x equals negative 1, and then you divide by 3. So that's one of your zeros. Then you set this one equal to 0, solve. That's one of your solutions. Set this one equal to 0 and solve. That's this one right here. Set this one equal to 0 and solve. That's this one right here. Okay? So I'm going to leave this on the board for you. Okay, now we're going to talk about multiplicity. The multiplicity of a 0 is the degree of its corresponding linear factor. Okay, so let's break down what that means. It's the degree of its corresponding linear factor. Let's just go back to an example here. What is the degree? Let me use green. What's the degree of this? 1. So the multiplicity is 1. What's the degree of this? Yeah, 1, because it's linear. What's the degree of this? 2. Okay. What's the degree of this? So that's multiplicity. The multiplicity for these are 1. Okay. So let's do an example. I'm going to do example. I'll do example 3 with you. Okay. So I do not have 4 terms. So that means I need to do a little eye chart so that I can get 4 terms. You need 4 terms for grouping. Okay. So if you don't have 4 terms, you need to create that 4th term. Okay. So let's go ahead. I need 2 numbers that multiply to 25, but add together to give me 10. Oh, 5 times 5 is 25. 5 plus 5 is 10, right? Okay, so I'm going to rewrite this as the x cubed will stay the same. The plus 25x will, oh wait, before I get started, hold on. Thank you. Say that one more time so the video can pick it up. Divide by x. We always have to divide by the greatest common factor before we get started. So let's do that real quick. This will become x squared. This one will become plus 10x. This one will become 25. Still, I need 4 terms in order to do grouping. If I don't have 4 terms, I need to do an eye chart. So we already decided that 5 times 5 will give you the 25 and we'll add to give you 10. So how we're gonna write this is x squared plus, I'll have a 25 on the end. The a value and the c value will stay the same. What changes is this middle term. Instead of doing 10x, I'm gonna do 5x plus 5x from right here, from my little table. We're creating the 4 terms so that we can group. Now that I have 4 terms, split it down the middle, and we're gonna do the greatest common factor. So what can these both be divided by? X. So x will be on the outside, and I'll have x plus 5 left over. That's one side. Okay, and then over here, what do I divide by? 5. So 5 will be on the outside. X plus 5 is left over. Okay, so I'm running out of space here. I'm going to come up top, but let me highlight one of my factors. Whatever is on the inside will be one of your factors. So one of my answers will be x plus 5. The other factor will be what's on the outside. So this x and this 5 will be your other factor. And guys, in the very beginning, we had an x that we divided by on the outside. So let's not forget that x. So those are your factors. X plus 5, x plus 5. Now let's talk about the multiplicity. Let's go ahead and solve. So you set this equal to 0. And what do you get? 0. And set this equal to 0 and you get -5. Okay, so those are your solutions. Now, let's talk about what the multiplicity is of these. How many -5s are there? Right? Because this one, if you set it equal to 0, you also get -5. So the multiplicity for -5 is 2. So for -5, the multiplicity is 2. Or you can put of 2. 0, it's a multiplicity of 1, because there was only 1 0. Does that make sense? Okay. So the directions for this part is to find the zeros of the functions below and state the multiplicities. So this is your answer. You state the zeros, which is -5. The multiplicity is 2. The other 0 is a 0. And then multiplicity of 1. That's how you do this section. Okay, so I'm going to have you guys do example 8. I'm going to have you guys come back to number 8. I'm going to show you guys how to graph these. Okay, so let's look here. We have x cubed plus 4x squared plus 4x. I'm going to go ahead and simplify this real quick. What can all of these be divided by? Yep, an x. All be divided by x. So we're left with x squared plus 4x plus 4. Okay, I need two numbers that multiply to 4 and add to 4. 2 and 2. Okay, perfect. So that means my factors are, I have an x on the outside, and then I have x plus 2 and x plus 2. Those are my factors. So my factored form is x plus 2, x plus 2. You need 1, 2, 3 factors because this is a third degree polynomial. Okay. Now, please write this down for your notes. When your multiplicity is even, the graph is tangent to the x-axis at that 0. When the multiplicity is odd, the graph intersects the x-axis at that 0. So let's talk about what this looks like. What are my solutions, guys? We're going to equal all of these to 0. So x equals 0 is one of your solutions. And what's the multiplicity? Yep, there's only one answer for 0. So this is multiplicity 1. And what's the other answer? -2. What's the multiplicity? 2, because we have 2 of them. Multiplicity. Okay, so let's graph it. Everyone, let's go ahead and graph the zeros. It crosses, or it touches here. This is a 0, and -2 is a 0. Now, we have to remember, odd polynomials look like this, don't they? Odd polynomials? Okay, so when your multiplicity is odd, it intersects. So, and when your multiplicity is even, it's a tangent, okay? So what this will look like, it will not go through, it'll come back down. Because when it's even, your multiplicity is even at -2, it's tangent to the x-axis. When something's tangent, it touches it, it doesn't go through, okay? All right, and it'll come back up and it'll go through the 0. Because if the multiplicity is odd, it intersects the x-axis at that 0. So it'll go through right there. So that is a rough sketch of what your graph would look like. Does that make sense? Okay, let me go back to that previous example with the same concept. This was our multiplicity, and it was a third degree. So remember, third degree polynomials look like this. Okay, our zeros were -5 and 0. So if I were to graph this, I'm going to say -5 is right there, and 0 is right here. Multiplicity of 2, that means it's just going to touch it. It's not going to go through. It'll go through the 0 because that one's an odd multiplicity. So that's a rough sketch of what your graph would look like. Okay? All right, so I'm going to have you guys do the other ones. And you guys can also, y'all can do the whole back page now. Let me just make something up for you. Let's say we had these factors, x plus 2, x plus 2, x plus 4, x plus 4, x minus 5, x minus 5. What are my zeros? -2, -4, and 5. What are the multiplicities of all of these? 2's. What degree would this be? It's 6 degrees because there are 6 factors. That means your graph would look like this, right? So my zeros, I have one at -2, I have 2 at -2, I have 2 at -4, and I have 1 at 5. So I know it has to go up at the end. But it's multiplicity 2, so it's going to touch. When your multiplicity is 2, they just touch. They don't go through. Okay? So this is all multiplicity 2. Multiplicity 2. Okay? So I'm going to have you guys try these. Do y'all want one more demonstration? Or y'all good? Yes.
I don't know if it's possible, but what would it look like if you don't just erase the pairs with it?
Okay, good question. Erase the pairs. So let's say I don't have this, I don't have this, and I don't have this. That means each of these are multiplicity of 1. And what degree polynomial is this now? Yep, it's a third degree because I have 3 factors. So it's going to look like this, right? So it'll go through here, through here, through there. Cause it's multiplicity 1. When it's odd, it goes through the point, through the point. It goes through. Okay, good question. Any more scenarios, hypotheticals? Okay. All right, so I'm gonna let you guys finish this page. If you'll have any questions, please let me know.